In this video, we're going to start looking at the binomial expansion. Let's start off with the definition of a binomial. A binomial is an algebraic expression with two terms. So for example, we might have 1 plus 3x. This is a binomial. We might have 2 minus 5x. That too is a binomial. We might just have a plus b. That again is a binomial. What we're going to do is look at expanding binomials in the form a plus b to the power of n, where n is a positive integer. It's a whole number. In this particular video, we're going to look at small positive integer values of n. In later videos, we will look at larger values of n, and we will also look at negative fractional and negative fractional values of n. So this now is my binomial. So I might, for example, want to raise this to the power of 6. I might want to raise this to the power of 12. I might want to raise that to the power of 4. And look at what the expansion gives us. Hopefully from our previous work, we know that this one isn't going to give us 1 to the 6 and 3x to the 6. If you're unsure on that, please go back and do some basic revision. We're going to move forward now and look at expanding a plus b to the power of n. If I start with a plus b to the power of 0, we know that anything to the power of 0 just gives us 1. What I'm now going to do is look at a plus b to the power of 1. Well, quite clearly this is just going to be a plus b. I'm going to write this as 1a plus 1b. I wouldn't do that if I was in an exam, but I'm just highlighting now the coefficient or the term in front of the a and the b. If I have a plus b all squared, we would have seen this expansion before. Of course, it's not a squared plus b squared. If we expand it out, we'll get a squared. So we'll have 1a squared. We will have ab and ba. ab is the same as ba, so we're going to have 2 lots of ab. And then finally, we'll have 1 lot of b squared, so plus 1 lot of b squared. Again, in the exam, I'd write a squared plus 2ab plus b squared. Now let's consider a plus b cubed. From this, we can see already our work is becoming quite a challenge. What we need is a more efficient way of expanding these out. So for example, if I was doing this one to the power of 12, quite clearly I wouldn't want to keep multiplying through. So what we're going to do in the video is look at a more effective way to do that. But let's just go ahead and do now a plus b all cubed. Well, I'm going to write this as a plus b multiplied by a squared plus 2ab plus b squared. All I'm doing is just taking this value right here, or this expression that we've got, and multiplying it through by another bracket. So if we start off with multiplying the a and the a squared, so I've got a times a squared, which is going to give me now a cubed. A multiplied by 2ab is plus 2a squared b. Then we're going to have now a multiplied by b squared, which is going to be ab squared. Now starting with the b multiplied by a squared, well, I can write that as just 1a squared b. b multiplied by 2ab, well, I can write that as 2ab squared. Remember, b multiplied by ab is the same as now the a squared, the a multiplied now by the b squared. And then we're going to finish off now with b multiplied by b squared, which is going to give me b cubed. Tidying this up, I've got 1a cubed plus 2a squared b plus 3, 2 and the 1, plus 3ab squared plus 1b cubed. So let's write this up here, and then we can look at the pattern forming. So we're going to have now 1 lot of a cubed plus 3 lots of a squared b plus 3 lots of ab squared plus 1 lot of b cubed. Again, I'm writing the coefficients out. So let's just go ahead now and highlight these coefficients. I've got 1, 1, 1, 1, 2, 1. I've got 1, 3, 3, 1. What this is building up is something we call Pascal's triangle. If we look at Pascal's triangle, and I write it just here, Pascal's triangle starts with 1, then we have 1, 1, then we have 1, 2, 1, we have 1, 3, 3, 1. Each time we start with 1, and the next term is simply the addition of the adjacent terms. So you can see 1 plus 2 is 3, 2 plus 1 is 3. So let's start the next row. 1 plus 3 is going to be 4, 3 plus 3 is 6, 3 plus 1 is 4, and we end up with the 1. If I do the next one, we're going to have 1, then we're going to have 5, we're going to have 10, we're going to have 10, we're going to have 5, and we're going to have 1. The next line, we're going to have 6, we're going to have 15, we're going to have 20, we're going to have 15, we're going to have 6, and we're going to have 1. So, what do these do? These provide us now with the coefficients we need on our expansions. So right here, this is the power of 0, this is a power of 1, this is a power of 2, this is a power of 3, this is a power of 4, this is a power of 5, this is a power of 6. Quite clearly, we can continue that. The longer I continue it, the harder it's going to be and the more time consuming. So let's split this up. We need 1, the coefficients, which are going to be these numbers, and secondly, we need now a pattern. So if we consider the pattern, if we look here, and I'm just going to write this out, what we've got here is a cubed b to the 0. Then we have on here now plus a squared b to the power of 1. Then we've got now a to the power of 1 b squared plus a to the power of 0 b to the power of 3. You will see that both of these powers add up to 3 all along, so 2 and 1, 1 and 2, 0 and 3, and that corresponds to this value right here, which is n. We can see the powers on the first term are decreasing from 3 to 0. They're increasing now from 0 to 3. So our second part of the pattern will be the following. A plus b to the power of n will give us now a to the power of n, b to the power of 0, plus a to the power of n minus 1, b to the power of 1, plus a to the n minus 2, b to the power of 2, right the way up to a to the power of 0, b to the power of n. So that's the pattern, these are the coefficients, and we simply go ahead and substitute in. So you might say, well, this is a lot to remember. It really isn't, and it's relatively straightforward when we look at some examples. So let's go ahead and look at some basic questions, and then in a later video we will make this more formal and introduce the idea of finding the coefficients by what we call the NCR method. But for now, what we're looking to do is use Pascal's triangle to find the coefficients when we're expanding a binomial to a small positive integer power. So for example 3, so for example 4, 5, 6, perhaps 7 or 8. I generally stop at 6 before we go to the NCR method. So let's just go ahead and try some, and we will now expand some binomials using Pascal's triangle. So let's just write up here Pascal's triangle. So if I've just got now Pascal's triangle, so 1, 1, 1, 2, 1, we've got 1, 3, 3, 1, we've got now 1, 4, 6, 4, 1, we've got 1, 5, 10, 10, 5, 1, and then we've got 1, 6, 15, 20, 15, 6, and 1. So this is what I'm going to use, and then I'm going to look now at my powers. So what we've got then is x plus 2 to the power of 3. So x plus 2 to the power of 3. I'm going to expand this fully. Now what I know is that I'm going to get the following. I'm going to start off now with these coefficients. These are the coefficients that correspond now to the terms if we have a cube power. So I'm going to put 1, then I'm going to put the 3, then I'm going to put the 3, and then I'm going to put the 1. So what we're going to have then is one lot of x to the power of 3, so just writing this out, and now at this stage you could put multiplied by 2 to the power of 0. I personally wouldn't. Then what we're going to have then is x to the power of 2. I'm dropping the power of x by 1, and then we'll have 2 to the power of 1. Again, I'm going to insert a positive here. Then we're going to have now x to the power of 1. I'm decreasing the powers of x by 1. And then we're going to have 2 to the power of 2. Then finally, we're going to have now x to the power of 0. And we're going to have now 2 to the power of 3. So if we look, this is just going to give me 1x cubed, or x cubed. This is going to give me 3 times by 2, which is 6. So that's going to be plus 6x squared. 2 squared is 4, 4 times 3, that's going to give me plus 12x. And this one right here, 2 cubed, is going to give me 8, and we're going to have 8 multiplied by x to 0, so this is just plus 8, and that has been expanded. Okay, so that's nice and straightforward. All we've got is the value of a as x, the value of b is 2, and the value of n is going to be 3. If we just look at the next one, we just need to be a bit more careful with this one. We've got now a is equal to x, b is equal to negative 3, and then n is going to be equal to 4. We just have to be careful when we've got negative quantities raised to odd and even powers. Straight off though, I know it's a power of 4, so I'm going to use this line for my coefficients. So let's go ahead and write this out. And we will do that. So what we're going to have then is x minus 3 to the power of 4. So x minus 3, and then we're going to have this now to the power of 4. So I know that I'm going to have now 1, 4, 6, 4, and 1 as my coefficients. I'll do these in different colours. So what we're going to have is x to the power of 4. And if you want, I'll do it this way. You can have now x to the power of 3, you can have x to the power of 2, x to the power of 1, and x to the power of 0. So this is just an alternative way of looking at it. Okay, now if we get a different colour, what we're going to have now is the negative 3, which is to the power of 0. We're going to have now the negative 3, which is to the power of 1. We're going to have the negative 3, which is to the power of 2. We're going to have the negative 3, which we need to cube, and then we're going to have negative 3, which we need to raise to the 4th power. So this might help you out, might not. It's entirely up to you on how you want to view that. So let's just put in these ones. So let's just put in some pluses just here. So plus, 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 and then plus. Okay, so if we look at the first one, 1 times by x to the 4th. Now negative 3 to the 0 is just going to give us 1. So this is x to the 4th. Negative 3 to the 1st power is going to give us negative 3. Negative 3 times by 4 is negative 12. And then we'll have x cubed. Negative 3 squared is positive 9. 9 times by 6 is going to give us 54. So we have 54x squared. Negative 3 cubed is negative 27. So negative 27 times by 4 is going to give us negative 108. So 27 times by 4, that's going to be negative 108, and that is x to the power of 1. And then finally, this is just going to give us now negative 3 to the power of 4, which is positive 81, and then we have x to the 0 and 1, so that's just 81. So that's what we get, x to the 4th, x to the 3rd, x squared, x to the 3rd, x to the 0, then we have the ascending powers. So if you prefer to see it like that, with me doing it term by term, it's entirely up to you. So nice and straightforward, and that is the expansion. Quite clearly we can see that if we had done 4 brackets now, that would have been an absolute nightmare. Okay, let's have a look at another one. We'll do 1 plus 2x to the 3rd. So with this one, what we've got is 1 plus 2x to the 3rd. So a is going to be now the 2x, b is going to be positive 1, and we've got n as 3. So let's have a look at this one. You could, of course, write this the other way around. You could write this now as 1 plus 2x to the power of 3. Entirely up to you. It doesn't matter. 2x plus 1 to the power of 3. So let's go ahead. We know our coefficients from Pascal's triangle. We've got 1, 3, 3, 1. It's the fourth line. So this corresponds to the power of 0, which we won't use. We won't use that one. We won't use that one, as we're expected to be able to expand a binomial with a power of 2. That's a power of 3. That's a power of 4. That's a power of 5. That's a power of 6. So we need this line right here, and I'll just write those out. So we're going to have now 1, 3, 3, 1. And let's go ahead and look at these. So what we'll have then, again, I'll do it in colour if it helps you. We'll have now the 2x to the power of 3. We will have now the 2x to the power of 2. We'll have 2x to the power of 1. And we'll have the 2x to the power of 0. If we now look at the 1, well, 1 is quite nice because 1 to any power is just going to give us 1. But I'll put this in anyway. It's a positive here, so we're going to have on here, that's going to give us 1 to the power of 0. We're going to have now 1 to the power of 1, 1 to the power of 2, and then 1 to the power of 3. So just tidying this up, let's go ahead and do that. We've got plus, 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 and let's do this then. Now, I need to cube this expression right here. It isn't 2x cubed, it's 2 cubed x cubed, which is going to give me now 8x cubed. That's going to give me 4x squared, and then we've got plus 3, so that's going to be plus 12x squared. This is going to give me now plus 6x, and this is just going to give me plus 1. So that's what we get. If we'd expanded it this way round, we would have got 1 plus 6x plus 12x squared plus 8x cubed. And that now is a full expansion. When we look at non-positive integer powers then, we will have an infinite series expansion. So that will continue infinitely. But if we have now a power of 3, then we have 4 terms. If the power is n, we have n plus 1 terms in our expansion. Okay, let's. We've seen this one, so we'll do a different one. Let's do this one right here. This 3 minus p to the power of 5. So what I need is my coefficients. If we go to Pascal's triangle, the coefficients are just here. At this stage, you might want to say, well, I'm going to use the NCR method to find the coefficients. We will look at that in the next video, but for now, I will use those coefficients. So we're just going to use now 3 minus p to the power of 5. So what we'll have then, if you want 1, we're going to have on here 1, 5, 10, then we'll have 10, 5, 1. So let's write this out. We're going to have 3 minus p to the power of 5. So I'm going to write this out differently in terms of the way I've done it with the different colours, so you can decide how you want to do it. So what we're going to have then is 1, then we'll have 3 to the power of 5, then we'll have negative p to the power of 0, plus 5, we'll have 3 to the power of 4, we will have negative p to the power of 1, plus 10, we'll have 3 to the power of 3, we'll have negative p to the power of 2, plus 10, we'll have 3 to the power of 2, we will have now negative p to the power of 3. We'll have plus 5, we'll have 3 to the power of 1, we will have negative p to the power of 4, plus 1, we'll have 3 to the 0, and we'll have negative p to the power of 5. So let's just look what's going on. 5 and 0 is 5, 4 and 1 is 5, 3 and 2 is 5, 2 and 3 is 5, 1 and 4 is 5, 0 and 5 is 5. The powers of 3 are descending from 5 to 0. The powers of negative p are ascending from 0 to 5. So let's go ahead and look at this. So on here, we've got 3 to the power of 5. 3 to the power of 5 is going to give us 243. If you're unsure, you can, of course, use a calculator. Certainly with larger powers and when we're multiplying, it's perfectly fine to use it. I sometimes do, just to ensure that I don't mess up. So negative p to the power of 1 is going to be negative p. This is going to give me 3 to the power 4. 3 to the power 4 is 81 times by 5. 81 times by 5, that's going to give me 405. So it's negative 405p. Okay, if we look at this, this is going to be negative p squared. Negative squared is a positive. This is going to give me 27, so that's going to give me plus 270p squared. Negative p cubed is negative p cubed. That's going to give me 9. That's going to give me 90. So we've got minus 90p cubed. This is to the power 4. Negative p to the power 4 is positive p to the 4th. 5 times by 3, so that's going to be 15p to the 4th. And then finally, negative p to the 5th will give me negative p to the 5th. That's 1, and that is our expansion. If we just look here, when we have a negative and an odd power, the answer is negative. If we have a negative and an even power, the answer is going to be positive. If we have a negative and an odd power, the answer is negative. Look at that pattern. So for example, if I was to expand 3 plus p to the power of 5, I could copy this out, but here I just have 243 plus the 405, then we'd have another plus just here, then we'd have plus just here, so that would be 90p to the 3rd, plus just here, and then we'd have a plus just there. So that is now just considering if we have a negative here and an odd power, the answer is going to be negative. Okay, let's look at this one right here. What we've got here is this binomial raised to the power of 1 and this binomial raised to the power of 3. In this particular case, when we have the higher power, all we do is use the expansion. So we use binomial expansion using Pascal's triangle or the NCR method and then multiply through. So what I'm going to do is write that this is going to be 1 plus x multiplied now by the expansion. So we've got now to the power 3, so we know the coefficients are 1, 3, 3, 1. So I'm going to get 1, I'll have x to the power of 3, then I'll have now plus 4 to the power 0, plus 3, we'll have x to the power of 2, we'll have now 4 to the power of 1, plus 3, we'll have now x to the power of 1, and we'll have 4 to the power of 2. Plus we'll have 1, we'll have now x to the power of 0, and we'll have 4 to the power of 3. So all I'm going to do is just tidy this up and multiply through. So 1 plus x, and then we're going to have on here, this is simply going to give me x cubed. Here we're going to have now 3 times by 4 is 12, so this will be plus 12x squared. This is going to give me 16, so this is going to give me now plus 48x. And this is going to give me 1 times by x to the 0, which is 1, and then plus now 64. So all we do at this stage is multiply through. So we'll start with the 1. So we'll have x cubed plus 12x squared plus 48x plus 64. Then we'll multiply through by the x, and then we'll have now x to the 4th. So let's write this just here. We'll have x to the 4th. Then we'll have now plus 12x cubed plus 48x squared plus 64x. Adding them together, x to the 4th plus 13x cubed plus 60x squared plus, and then we're going to have, what's that going to be, 114, so 112, sorry, 112x, and then we got plus 64. So that is the expansion that we've used by simply using the binomial expansion with Pascal's triangles for the coefficient and then multiplying through by the bracket with a power of 1. If that was a power of 2, I'd just expand this as 1 plus 2x plus x squared and then multiply through. Hopefully you can see though in this particular situation we go ahead and expand the bracket with the higher power and multiply through. Okay, let's go ahead and look at one more question. In question 2 it says find the expansion of 3 plus x to the fourth, and in part B it says hence find the expansion of 3 minus x to the fourth, and then 3 plus y squared to the fourth. So what it's saying is if I expand this out, I shouldn't have to expand these out, I simply make an adjustment. So let's go ahead and use Pascal's triangle, 1, 4, 6, 4, 1. That's going to give me my coefficients. So let's look at this then. What we can say then is 3 plus x to the power of 4 is going to be 1, then we'll have 3 to the power of 4, we'll have x to the power of 0, plus 4, we'll have 3 to the power of 3, we'll have x to the power of 1, we'll have 6, we'll have 3 to the power of 2, we'll have x to the power of 2. We'll have now 4, we'll have 3 to the power of 1, we will have now x to the power of 3, and finally we'll have 1, we'll have 3 to the power of 0, we'll have x to the power of 4. So do check that these all add up to 4. 4 plus 0, 3 plus 1, 2 plus 2, 1 plus 3, and 0 plus 4. So if we write this out, what we're going to have, 3 to the power of 4, we've already seen, that's 81. This is going to give me now plus 108x. Then we're going to have now plus, what's that going to be, 54x squared. We're going to have plus 12, what's that going to give us now, 12x cubed. And then finally we're going to have plus x to the power of 4. So that is the expansion. Okay, so now what we've got here, if this was a plus b, so what we've got here is a plus b. On here we would have now a is equal to 3, b is equal to positive x. On this one we've got a is equal to 3, but b is equal to negative x. So if I write this out, we can say that 3 minus x to the fourth is going to be, again, 81. Now this time it would be negative x in here, which means that this to the power of 1 would be a minus, so it's minus 108x. So every time I have an odd power with a negative, it's going to give me now a negative answer. If we put the negative x in here, or square it, that'll make it positive, 54x squared. If I put the negative in there, it'll make it negative, and negative cubed is a negative, so it'll be minus 12x cubed. And if I put the negative x in there, that will be plus x to the fourth. So in some questions, you might be asked to do a question such as 3 plus x to the fourth plus 3 minus x to the fourth. All you do is add them together. These positives and negatives would drop out, and you'd have 162, 108x squared plus 2x to the fourth. Okay, let's just do the next one. What we've got here now is that a is equal to 3 and b is going to be equal to y squared. So what we're going to have here, let's just write this out, 3 plus y squared to the fourth. You're not expected to start this again. So if we just pick this one up here, what we're going to have is 81 plus, now this is going to, instead of x, it's going to be y squared. So this is going to be plus 108y squared. If we then consider the next value again will be 54, but we're squaring this bracket. If we square a squared term, we get y to the fourth. On the next one, we're going to have the 12, but instead of x cubed, we need to cube y squared, which will give us y to the 6. And then finally, we're going to put now y squared in here, so it'll be plus y to the power of 8. That's all we've done. We simply substituted this in and considered what's going to happen with the powers. So there we go. That is binomial expansion for positive integer powers of n. So for example, 5, 6, 7, 8. We've looked at small values of n where we can use Pascal's triangle. Quite clearly, the 7th, the 8th, the 9th, the 20th, the 50th line, that's not going to be reasonable to expand it like so. So what we're going to do in the next video is look at another way of finding the coefficients. The same process will happen in terms of these powers right here on our a and b. We will just find a new way a quicker way of finding what numbers go in front of each term.